me, it's a big inspiration. I'm very passionate about the subject. I'm very passionate about doing the subject correctly. And that's the reason why I've got these meetings. Now, first of all, last year, end of last year, we haven't had much time to do a grade 10 um, virtual meeting explaining the subject information for this term. But if I can scroll down to the annual teacher plan for the grade 10s, this is basically what we have had up to so far. Introduction to EGD, that is basically um, job opportunities and those type of things that you can have with the subject itself. There's also a lot of PowerPoint slides on the web and also on the teacher's Google platform with indicating all of that. And then also the drawing equipment, and then the line types, type B, type C line types, and also, of course, the more important type A line types. And then also civil title block and mechanical title blocks. Ladies and gentlemen, what I have did with my learners yesterday when I did my PAT, or last week, when I did my PAT, I clearly explained to them the difference between mechanical and civil name blocks. There's also an exercise in your workbooks indicating a freehand sketch where the civil name block piles up onto one another like buildings going higher up. And then the mechanical title block is, of course, like vehicles that needs to travel from left to right on roads. So therefore, it's horizontal for mechanical title blocks. Right. And then also ratio of scale. Now, I can in 3 minutes explain to you what the difference is between ratio of scale of 2 to 1, 1 to 2, and 3 to 1, and 1 to 3, and all those type of things. But please don't bear in mind that 50% of the National Senior Certificate Exam Paper 1 consists of scales, where learners have to work and deal with scales. So please make sure that you do the ratio of scales very thoroughly. And then we have had freehand sketches and bisecting of lines, geometrical constructions, 60 degrees, 90 degrees, 120 degrees. We have had also the construction of an angle, copying of an angle, internal common arcs and external common arcs, and also tangent internal and external circles or arcs towards circles. All right, so that is also important, because if you set the exam for you guys, for instance, you can ask a mix and match of all these combination of all these type of questions into one question. You've seen the workbooks, you've seen how does it look like, and all those type of things. And then, of course, it rolls over towards polygons. What I want to point out to you about polygons, just as important as what it is for grade 10, it is also applicable for grade 11 and also for grade 12s. All right, so why do I say so? Simply because of the fact that in last year's National Senior Certificate exam, in the 2-point perspective, there was a hexagonal swimming pool. And many of the learners said, no, they've never been taught how to interpret, how to do a hexagon in a 2-point perspective. It's irrelevant. It's basically the principles to be applied for the perspective, but the construction of it comes from grade 10. And solid geometry, the interpenetration and developments. If you go further onwards with isometric drawings, there's a lot of isometric drawings with pentagons or hexagons, non-isometric lines in it. And then besides that, it's also nuts and bolts, where there are also some sort of information requiring the construction of polygons. Okay, and then we have got the PAT part. I believe most of you have started with the PAT already, and the PAT exam, like I said, it's explaining it very clearly to you. And then, of course, still continuing with geometrical constructions, it is basically the ellipse. There's 2 different types of constructions of the ellipse: concentric circle. It can also be the forced center ellipse. And then there's a lot of exercises involved with that. But now our focus is not this term's content. Our focus is term 2 for grade 10s. It will be mechanical drawings. Remember, this can also be mechanical. I will explain that to you just now in a few moments. But it can also be mechanical analytical questions, and then also mechanical drawings in terms of front view, left view, and top view. Remember, from mechanical drawings, it is third angle lithographic projection. I will explain that to you also just now. And then mechanical analytical, the symbols that you can get there, dimensioning. Ladies and gentlemen, if you will see, if I will, in a few moments, I will go through the report of the external moderator for DBE and what are the problems learners are experiencing in terms of grade 12 during the National Senior Certificate exam, where learners are still struggling and not being taught thoroughly. I said the other day at the principals meeting, you know what, for a grade 10 teacher is as important as what the grade 12 teacher is. In the sense of the grade 10 teacher needs to explain and to assist the learners with polygons, assist the learners with the application of line quality, line work, the application of center lines. The grade 10 teacher must teach the learners about the third angle lithographic projection and first angle lithographic projection. So all of that is featuring from grade 10 content. And then if you start reading through the reports of the external moderator and examiner, you clearly see that there's a lot of information that comes from the grade 10 content itself. All right, so this is for next term. It will be mechanical analytical, it will be mechanical, and it rolls down to isometric drawing. So I'm going to focus on these three topics. I've got in place over here principles of title panels we've been spoken about. Let me just put it on PowerPoint mode. This is the mechanical title panel. You can see it's horizontally. The learners don't need to remember what exactly is standing over here. That's just as long as they can recognize the horizontal one is a mechanical, and it's horizontally because of, let's say, cars driving horizontally on roads and those type of things. Okay, and then from there on, mechanical analytical drawings is loci of cams. Of course, that is grade 10, it's not grade 11 for cams, and grade 12 loci of mechanisms and cams, and then isometric and mechanical analytical drawings, or sorry, mechanical drawings. Now, mechanical analytical drawings and mechanical drawings goes hand in hand with each other. You will see if we go through the SANS, it's watered down. It's not as thoroughly as what it is for the grade 11s and grade 12s, but they are hand in hand, goes together in terms of the information that you will get there, right? This is now a very advanced National Senior Certificate exam layout of a mechanical analytical. But what I can say to you, that is your questions that you will have. Over here, you got your title panel. It is not to say that go from left to right throughout the whole paper, as long as it is horizontally. Right, then you've got your part list, and then from there on your parts itself, and then if you go from there further onwards, you will see that you do have got your low order, your middle order, and your high order questions as part of this question. Normally it's 30, 40, 30%, but it's supposed to be in that vicinity. Okay, third angle lithographic projection. I used to say it's like a guy walking around with the steer's ice cream cone, and he tripped over something. Obviously, if he's standing and walking it with his right hand, he will not want, doesn't want to have the ice cream falling on him. So if we will flip it out to the right hand side. All right, so what you see is the cone is bigger to the right hand side as it's been flipped out to the right hand side. And then with his girlfriend walking next to him, the ring will be on the left-hand side. So whatever you see on this side, you will place the rings on the left-hand side, like your ring finger normally will be on your left-hand side. So therefore, the ice cream goes out to the right. Your ring will be on your left-hand side. So that's the way this symbol will be asked. It's been asked numerous times. I can't tell you how many times it's been asked. So therefore, the same with the views. If that's the front view, the top view will be above, and the left view to the left, right view to the right. So if it stands next to each other, it can be the front view, left view, or right view. If it stands on top of each other, it gives away the game by saying this must be the front view and that must be the top view. All right. So the same with section drawings. This is a model. This is what the grade 10s can expect. If it's been cut, you will show in which direction it comes from. So therefore you will reverse on your position, and then from there on you place it on the left hand side. The arrow is also pointing towards the hatch lines over there. All right. So you can ask something like, where is the bottom answer? Where is the bottom view? Where's the left? Where's the right of these view 1, 2, 3, 4, and 5? Like I said to you, the third angle geographic projection symbol has been asked numerous times. So learners to draw it, they must remember a few things. They must remember to draw the vertical center line, and then of course also the cone to the right and the rings to the left hand side. Okay, it was asking 2025 as well. It's not mentioned over here, but here you can see it over there. And what projection system is indicated, that was given in the past. They ask, show, or draw in the place below the projection system required for this system. All right, these are the castings, the let me say it, things like, for instance, a complete drawing, one unit. In other words, it's not assembled. It's just basically a casting of one unit. All right, so there we go with that part. You can see if you project it down, you will not be able to see these parts. You cannot see those parts over there, and that's why line quality presents you to hidden detail. If we go to hidden detail, there's a few things that makes it smarter to balance the small little lines to either side of the solid line to end up in the corners or in a T or in a Y position. If it goes from a circle ending off with a long line, starting with a new line, so therefore it goes from there further onwards. If you've got a solid line and it turns over to a dash line, then in that case you will be able to have a gap over there and not starting directly from that point itself. All right, and then the same with the arcs, also leave a gap open. Then also dimensioning. Now remember, it's not required from them to do dimension unless for the PAT. All right, so in exam papers, they don't normally ask dimensioning, but in the PAT, they might have to give dimensions. So you have to explain the learners the detail of extension lines, the gap before you start with the extension line, the extended line on the extension line itself, the dimension line, how to draw the arrow and how to draw it properly. That is basically pencil width to the left and to the right side of there. Can I just perhaps ask? I've got on the other screen, I've got the presentation as well. So if there's someone who can just allow the people onto the lobby, it will be appreciated, please. If you know how to do it, you just allow the teachers in there. All right, so for the pencil with the arrows, it's thin lines, it's not thick lines. What you're going to use, if you do the dimensions, first the small ones, then the larger ones to the outside. You can also have a intermediate dimensions and then also a total dimension on the top. Over there, normally the distance away is about, give and take, 10 millimeters, and then 10 millimeters for the rest of it. These gaps and the extension is about then, since you're 4 millimeters, there's also the arrows is normally about 3 to 4 millimeters long. And then abbreviations or acronauts, or what you call those things, what you will get in front or before you write your dimension. In this case, it's pointing out to you the dimension of side to side of a circle. So that's going to be diameter. In this case, it's from the center outwards. So that's radius. It's an R. And ladies and gentlemen, this sounds simple. But in 2025, I forgot to put it in. In 2025, there was a question asked, and then at 2 occasions, it's either the one was the M for a dimension before you get, or for when you get a nut or a stud or something like that. And the second question was because of a diameter. And if the learner don't put the diameter in front, or if a learner don't put the radius in front, he's losing a half mark for that. So you can't get full marks for that specific question. This is your third example where there's an M for a nut or something like that for metric sizes. And then if it's a square, a learner must put a square in there. And then, of course, like it was asked in the past already, and if it's a sphere, spherical shape, is SPH. All right, so that's what you can get. Then, but more to a grade 11 standard, you will get PCD, pitch center diameter in Afrikaans, SSD, steek circle diameter. So I'm not going to bother too much about this for the grade 10s, but yeah, please, the other ones are very important. So please make sure that the learners understand that. And then the last one is NTS. So there's quite a few information that you can get either in front of or behind the dimension itself. This is not to scale, or even if it's underlined, it means also not to scale. Okay, so now this is your typical low order question that you can ask for a grade 12 learner actually, but in fact I wonder sometimes, I think it's actually a high order question, because they do ask the dimension of the thickness of this part over here. You have to have the information or the knowledge to say, this is the front view, that's the top view, and that gives you the top view distance. They ask it in the top view, and if this is the right view, they will give you the dimension, in other words, over there. So that is the dimension being given to that point. All right, the height of it, sometimes you have to build it. Over here it says 103, but you must remember that that little knob, it's not this one per se, it's this one over here, and it says 8. So you have to add the 8 millimeters to the 103 millimeters, which is basically this plus that part over there, and that gives you the total height of that part. So that becomes now a middle order or even a high order question, because it's not all in the same line. It's not given there, but it's given as an auxiliary view. And then for this one over here, they give you the total height from there to there. They ask you, what is this dimension? And now this is basically a low order question, because if you subtract the 29 from the 46, you will get the distance remaining for this specific part over there. All right, so these are the type of dimensions that can be asked. Of course, yeah, you have to also add 3 and 29 and 46. So if you add 23 plus the 29, it gives you 31 minus 46. That will give you the dimension for this part over here. Okay, and then this is last year's exam paper. What's the dimension at G? Now, if you search for G, let me see if I highlighted it. Yes, there's G over there. That is the diameter which is inside there. That is the outer diameter. And those are the things they're talking about when they will screw it in over here. And it's a pin die, in other words. And then that pin die is a M10. All right, so again, can you see the M in front of? And this is what I've explained to you earlier about all these acronyms that you can get in front of a dimension. All right, so please make sure that the learners do understand this portion of dimensioning. It can become a middle order, it can become a high order. So likewise over here, J, the distance of J, because it's an M6 bolt, it means this is the sightline information, which can confuse the learners. It's nothing to do with this dimension over here. It says M6 build, so therefore the dimension should be M6 in that case. All right. Okay, principles of photographic and third angle photographic projections. Now, what you understand about third angle photographic projections, this is what you will have. It's a front view, top view, front view, and left view. The right view should have been on the right-hand side, bottom view on the bottom. This is a more complex casting of what the learner can have for to be drawn. That is the front view, and that is of course the top view in that regard, and that's the right view placed over there. Now this is grade 11 and 10, 11 and 12 content. This is the moment that you get 2 or 3 parts that needs to be assembled. That will bring you assembly drawing. So that is not applicable for the grade 10s. Section lines, those are applicable for grade 10. On grade 10 content. That is the cutting plane. In other words, it cuts it off. It means that has been cut off at that specific point, and then of course the arrows has been placed. This is a section line on a A. All right. So if I saw it off, I need to remove the part that's in between me and the object. And once it's removed, I will see the saw marks. Now, please don't teach the learners those are the saw marks. It's the hatch lines. So if I cut this off at that point, at AA, it means that while now it's not visible for the circle itself, it will become visible because now I can see those lines going down there. And that's what you will see, a solid line, hatch lines, and hatch lines on the other side. Why not hatch lines in this part of the year? Because it's never been sawed up or cut by me. It's been cut by coming out of the factory itself. All right, so this is the section line that we were talking about. It's a center line. I used to say it's a very sharp line, so it has to have a handle on either side. It has to have arrows. The arrows can be a little bit bigger on either side, of course. And then it must be on either side, and it's called something, all right? So therefore, this view was the front view, but it will change now to a sectional front view on AA. So that is what you have to understand. Now, what I used to say is if you have to put the arrows inside here, you can remember you can put the arrows like in the case of the PAT. It's required from the learners to do to show the section line in the top view as well as in the left or on the right view. The tail part of it's like these dogs over here. The tail part of it will be always pointing towards the damage the dog has done. If I chase this dog away, it will run into that direction, and the tail will point towards the damage. If it's running into this direction, the tail of the dog will show the direction of where it's been sectioned, and the same with that one over there. All right, so that is important. If it's been sectioned over there, this they ask in the National Senior Certificate exam, but it can also be an analytical question for the grade 10s, is show the arrows inside this part. If this is the section view that you see over here. All right, where's the damage? Over there. Where will the dog run to? The dog will run away from the damage caused. That means the tail will point towards that part, so the arrows is pointing into that direction. It's a low order question. It's a for grade 12s, but it's for 10s, it can be a middle or a high order question. Okay, and then this view, like I said, is called the sectional or sectioned front view on AA. It's been sectioned. It's not the front view. How many times it happens that the examiner is asking name view 1, and then the learners write down front view. It's wrong. It's the sectioned front view or the sectioned right or left or top view. Okay, if view 1, oh, there's a spelling mistake, is the front view, what will view 2 be called? In other words, if this is view 1, that is the front view. So it will be seen from the side, it's on that side. So therefore, it's the right view. Yes, I agree with you. But it has been sectioned over here. It's sectioned on those areas. So now it's not the right view anymore. It's a sectioned right view. So please make sure that you teach the learners the correct way in doing these things. How do I do my hatch lines? Ladies and gentlemen, please don't let the learners go for small millimeters. Let them go for 7 millimeters and measure the 7 millimeters and draw all those lines one after the other one. So you can also let the learners draw a little line over here with by means of a sharp object on the set square, and then the moment the line on the set square is overlapping with this line over here, they can draw the next one, and that will give them a significant distance. What does the examiner look for? If it gets to the end of the year, he's looking for hatching that one, it's made from a type B line, and 2, it have to have a lines that is separately apart from each other in a constant sequence, right? So it's not 7 millimeters and then 3 and then 7 and 7 and 7 and then 2 millimeters and so that is what it's looking for. If it stands slanted, you can go horizontal. If it stands slanted, you can go vertical. And if it stands up straight, then you can go on 45 degrees. You can hatch on another degree as long as the degrees are constantly the same, but preferably on 45. If you go to sectioned isometric drawings, you will go on 60 degrees, right? So that is basically what it points out to you, right? Then over here, if the hatch lines, this is actually grade 11 content, but if there's 2 materials involved, you will alternate between the direction of the one object towards the next object. And if there are 3, then 2 of them will be in opposite directions, and then the third one will be closer, smaller to each other. Then you can go 5, but normally the one with that will be taking up the least distance. This is actually a grade 12 question. This is civil. It's not, I'm not going to explain that. What the learners must know about grade 10 content in that is if they are sectioning through a rib, which is this part over here, which is that part over there, they may section through it, but they have to fence it down and say this is the area of the rib. And normally, because of the fact that it can be significant in a lot of detail over here, they don't need to do hatching inside the rib or a web itself. So there we go. Cut it off. part in front of you has been removed. So this is in other words, the part that has been sectioned. Now, if I take a look at this, it's been cut off there. So I fence it off and I don't do hatching on ribs itself. All right. So there's 2 ribs on either side. Again, I can get a section line cutting through this part over here. It means section off. This front part will be removed. Take your ribs of the drawing, and then from there on, you show this in this view over here. But yeah, just be careful because there's hidden detail lines at the front and at the back. There's over there, there's a hidden detail line over here while it was still covered, but now it's been cut off. So therefore, these lines will become solid lines now. At the back there will be also hidden detail lines, and at the bottom there will be hidden detail lines. If you section it off there, it means there's no sectioning that is going to take place on either side over here. Hatching on that part. This is also, it's not always a triangle. It can also be something like this part over here. There is a triangle being given. Then this part is solid. You can see it. So if you cut through it, you will only see the dash lines that will become solid lines in that case. And then everything will be hatched. Why? Because it's not a rib. The whole object is basically shown as what it is over there. You also, if you do hatching, you can leave out an area for dimensioning. You can also, if it's significantly large, clean up the areas over there. Hatching is important. Now, this is an assembly drawing, but nothing prevents me to put a round cylindrical object here somewhere. And remember that cylindrical objects like pins, like shafts, like bolts, like studs are not hatched. This area over here is cylindrical, yes, but it is hollow. So therefore, that's where the thread is. So therefore, that's no hatching over there. Not going to spend time on the hatching of thread in the grade 10 content because nuts and bolts is not involved with grade 10s. All right. So, but then if there's a rib, a learner can't get the marks for hatching, not hatching on the rib if no hatching has been applied. So therefore, you must teach the learners that their last 5 minutes they must do some hatching simply because of the fact that they will get and gain and benefit from it for the areas where there's no hatching involved to get the marks for that specifically. All right, so that's what it is over there. What do I don't hatch or cut through? Rivets are too small. Rods, like last year's June exam, if I can remember correctly, for the grade 12s, there was a piston rod. That rod, no hatching will occur on that part. Threaded rods, you don't do hatching on that. A normal rod like this one over here, no hatching applied. And then also dowels. If you take a look at dowels, you can chop the head off and you can do the hatching like this, quarter to quarter, or sector to sector if you see it that way, but in the length you normally don't do hatching. Pins are too small, it's too thin, so therefore no hatching applied onto pins. Then also over here there's a hole being drilled in. If I cut and I drill the hole in over there, it will be basically visible like this, and then you do the hatching. All right, like I said, with the grade 11 and 12 content, there's screw threads. So I'm not going to explain that. It's not applicable for grade 10s. Washers, you don't do hatching on. With studs, like this one over here, no hatching to be applied. And that's the use of the stud, because you can't have a bolt that goes right through a nut on the bottom of this block and then at the top of this block and so on. So therefore you make use of studs to turn in there. And is there a question? Perhaps someone is asking a question, or is it just not that your device is not mute? So please, ladies and gentlemen, just make sure that your device is muted. Someone is talking on this one. It's Maduka, Lucas Matloki, Mr. Matloki. Mr. Matloko, your device is on, so please just mute your device, please. Let's see if I can do it from my side. It's muted now. Thank you very much. All right. So, okay. So these are the bolts. Normally, you will also not do any hatching on bolts on the hexagonal bolt, but that's for grade 11 and 12 content. It's not for grade 10s. And then the alternation between the bolt and then the threaded part of the hole inside this object over here, that will be hatched over there. Also grade 11 and 12 content. Nuts, grade 11 and 12 content, no hatching. A tin is too small, so therefore we're not going to do any hatching on a tin. So it's just a solid line. Keys. This is the key, different types of keys that you can get, Woodruff keys and cube head key, and the square or the rectangle flat key are the most obvious keys that you will get. There's also the del, no hatching to be applied on this part over here. That's the purpose of the key, just to indicate to the learners and show them how it works as a unit. So therefore it's inside there. Now, ladies and gentlemen, in grade 10, you are allowed, you can ask the learners to do part section. We will get to part section just now, but they have to understand if a cylindrical object has got detail inside, you have to bite off a piece because you can't hatch through rods and those type of things. So you have to do a part section to indicate the detail inside that part over there. Okay, so there we go. Offset sectioning is grade 11 content. I'm not going to go through the detail of offset sectioning. It is basically inside the whole model or part. It's not going outside. That's offset of awaken the snit. And then if you go to, there's no response over here. There we go. The handles for each blade that you're going to use to cut this part. It has been asked quite a few times. And then a half section is when it goes outside the object. So therefore, this one goes outside the object. And that will be shown to you in this regards over here. There's a hollow part or a hole inside. So therefore, it stays a center line. And if it is a solid part over here, it becomes a type B line if you cut through a half section of a half snit. All right, so therefore it becomes a type B line here, and you do the hatching on the inside over there. This is detail inside this part. Partly section has been applied, so this is for grade 10 content. They have to know exactly how to apply detail in a cylindrical object. All right, so there we go. You can also do part section in this line over here. Both of these examples are the correct examples, and there's nothing wrong with that. All right, so it's been asked quite a few times in National Senior Certificate exams. Revolve section not required for grade 10. This is what it will look like, and it's been asked quite a few times over here. Removed sectioning, not for this grade 10s over here for this year, so therefore I'm going to go faster on this part. Successive sectioning is not grade 10, it's grade 11 and 12 content. And then that is how many times it has been asked. And then aligned section is also grade 11 and 10 content. I'm not going to use and waste time on this part over here. All right, so that's the aligned sectioning. Presentation of features, not for grade 10, but you can expose them. You can show them these conventions. It's basically a shortcut for the learners to understand this is what it will be look like. I'm not going to draw all the detail in terms of that. Okay. Gears, also grade 11 and 12 content. So I'm not going to go through that detail, how they fit into one another. And for nuts and bolts and studs, you can explain to them what is a nut and what's the difference between a nut and a bolt. And you can explain to them what is a stud and where do you apply the principles of a stud. But the detail of it, you don't need to explain to grade 10 learners, because grade 10 learners do not require to do nuts and bolts to be assembled in the process. Ending of a shaft, you can. Why? Because it's been asked numerous times. In some exams, 6 times. Some exams in 23, 8 times for the same question. So what I want to say is, this is a very obvious question that will be appearing in every National Senior Certificate exam. And you can teach the learners how to deal with this 45-degree. Don't go into too much of detail about the threaded part, but if you end off a shaft, normally it will be chamfered, and that's the way that you can show that. Interruption of a view, grade 11 and 12 content. The S-brake for a pipe, grade 11 and 12, and for a solid square bar, it's also 11 and 12 content. And how many times it has been asked. Flat surfaces is grade 11 and 12 content. And then this is a spline. This is the way you will show the spline. This is also a serrated spline where it's teeth or gears that's basically in there, and that's the way you're going to show the serrated spline itself. Okay, and then parallel knurling. I think it's something familiar with them, so you can explain that. Normally, your radio knobs, your jump bars, and those type of things, all has got knurling. This is parallel knurling, and this is also diamond knurling that you can get. What is important about knurling is the fact that there must be a side open towards the insides of this part over here to show the detail is inside and not from top to bottom, left to right. All right, and then this is a circlip, grade 10 and 11, sorry, 11 and 12 content and application of that one. Springs 11 and 12, this is the symbol that you will show to them. There's also a square spring showing there's a square in there, so that is basically pointed out to you there. And then a compression spring, a conical helical compression spring. Why compression? Because if it stands like that, and if you compress it, it will jump back to the original position, right? But conical, like a cone, it goes up to that position. And then this is a tension spring. It's always in the tension. It's always to the minimum. And then if you hook it and start stretching it out, it will become tensioning back to its original position. All right. So this is your tension spring with a barrel shape. So you can see the barrel shape over here. Curved shape, in other words. We follow it is a spinning sphere. Then you got the bush. This is also applicable for compiling 2 or 3 parts together. So that is your bush that you will get. And then a bush with a shoulder. There's the shoulder you can see over here and what it will look like for the front view and top view. And if you section through this part, this is what it will look like. So we are not really into this part. It's basically with assembled drawings that you can get that. And then also a spot face going deeper in. It can also stand out. There we go with another type of spot face, although the examiner didn't want to allow this as a possible answer last year. Still wondering why, because it's in his own textbooks, pointed out that way, that he doesn't want to see it as an alternative for spot face. And then if it's deeper than 4 millimeters, it becomes counterbore. All right, so it looks the same as the spot face over there, but the difference is it is now 5 millimeters or larger. All right, so that is also maybe you can add this as a view for the grade 10 learners and explain this part of that for the grade 10 learners. It's showing to them no hatching is taking place in certain areas. All right, then center lines. Ladies and gentlemen, there's a lot of questions in terms of center lines. If you go to the first question for paper 1, is this, the second question will be, for instance, the symmetry of a pentagon and a hexagon and everything that goes with that. The symmetry of cylinders and pyramids and prisms. The symmetry of circles being drawn. Right. If you go to the, for instance, the 2-point perspective drawing, you will actually supposed to show the center lines in there as well. If you go to paper 2 with the analytical of the third angle lithographic projection symbol, there's a center line over there for the first question. For the second question, it will be cams and it will be loci of mechanisms, where you have to show the center line of that movement where it starts on the shaft itself. If you from there on go to isometric circles, you are supposed to show center lines in there. If you go to any hole drilled into assembly drawing, any cylindrical object, any nut, any bolt, any shaft, there's a lot of center lines. So this is very important to show the learners, because learners are losing a lot of marks. Last year it was with the analytical question, it was with the cams, it was with the isometric drawing where there was a circle involved, and there was mechanical drawing. So therefore it was about the vicinity of 4, 5, 6 marks learners lost because they don't put in center lines. So from the start, teach them the importance of center lines, symmetry of prisms, symmetry over there, and then of course the symmetry, application of symmetry, where you can say that this is equal to that, since the bottom and the top part is exactly the same. So that's the symmetry principle that you can show to them. Symmetry principle applied. Principle of symmetry being applied from top to bottom. Principle of symmetry being applied into this part of the paper. Symmetry being applied over there, 2025. There was also symmetry to be applied into that. And then also center lines for the convention of repetition of information that can be asked in a grade 10 question paper. Why? Because it's a unit, it's one single object, and then the learners can draw the detail of it, showing the symmetry to either top and bottom and left and right. This is for the crank, for loci of mechanisms, where the center line is applicable. Possible position of a spring-loaded object, that is center lines. Then, of course, detail Z, don't need to explain to learners. Then mechanical drawing sectioning, there we have detail. I'll ask you what is view full will be called. All right, so therefore it comes from this part, so it's detail T. And then repetition of the convention of repetition of linear pitch that we use the center lines for cylindrical or circular pitch. That is the one that you show, and then the center lines indicating the rest of it, and the repetition of features that is basically showing only the center lines. So center lines is very important, and you can get a lot of marks in terms of that. All right, so this is now the welding and the tolerances. None of this is for 11 or 10. So therefore, I'm going to go out at this moment with that part. With the second, let me just quickly see if I'm not busy with the same PowerPoint presentation. No, for nuts and bolts, ladies and gentlemen, I'm not going to go through the detail of that simply because of the fact that I said to you earlier, show them what a nut is, show them what a bolt looks like, show them what a stud looks like, and where's the applications for that, but they don't need to understand and do any of nuts and bolts in this regard. All right, so therefore, this is not applicable for grade 10. You can simply just leave out and skip this portion of the content of the PowerPoint slides and showing that to them, or to show that to them. What I want to show you is this last part over here, how to orientate your paper to understand that the drawing will fit in onto the paper. You can't simply just divide the paper into half if they ask for the top view, right view, and bottom view, and divide it in half and then start with the drawing, because then most of the drawing or some parts of the drawing will be off the paper and there's plenty of space still left over. So you have to explain to them how do they orientate themselves. So if that's the front view, right view and top view, that's going to be fitting there, they can make use of the front view, and the total length of the front view they can measure in over here. For the right view, the total width of the right view or the depth of the top view, they have to fit in over here, and then this remaining part can be divided into two, and then from there on you can go 10 to the left and 10 to the right to get the lines over there. Same with the front view and the top view. What's the total height of the front view that you're going to use, and what's the width or the depth of the top view that you will need for, and then this distance can be divided into half, and then you can actually go 5 up and 5 down. You don't need to go 10 up and 10 down. And then, of course, you start applying your drawings. That is easy because it starts in the corner. But this one over here, it's overhanging towards that position over there. So therefore, I have to take that position and place that position in and over that specific point. The same with the right view in this case. It is going to be that point that's going to fit in onto that position over there so that you don't overlap this part over here. All right, so that is now equally spaced for left and right, top and bottom. And then that is what you have to understand, or what you have to explain to the learners itself. So I'm not going to go through this detail over here. There's also a third slide, which is the one that I've showed you just now about the orientation of the page. So I'm not going to go through that detail either. And then the last one is for isometric drawings. So we are to the last topic. I'm going to make this up to a larger scale. Can I perhaps just remind you that if you have entered the meeting later, please just submit your, click onto the link and then from there on, you will see the link is over here in your chat box. So if you click on that chat box, you will find it over there. Click on the link, and that will take you automatically to your attendance register. Ladies and gentlemen, a few things about isometric drawings, just the following. What I want to say to you is that is your three-dimensional view. Many learners, this is one of the most difficult parts to explain to learners exactly how to see a isometric drawing, right? Because it comes from a 2D drawing and you have to convert it into a 3D drawing itself. All right, so therefore you will have your depth, your width, and your height. It's like a drawer. The width of the drawer, the height of the drawer, and how deep you can put your hand into the drawer is the depth dimension that you will get there. All right, normally it's 120 degrees, but we all know we work on the 30 degree, and 90 degrees for this part over here. Okay, so that is with your 30, 60 degree set square that you will be using. If that is the information, you need to convert the isometric drawing or the two-dimensional drawing into a isometric drawing. All right, so that is making it stand on one specific point at that point itself. All right, it's good advice to draw a freehand drawing first, what you see about this part over here, and then draw it. And then also, if the left view has been given, you must understand that the left view will be starting with, and then from there on the right view will be on the right hand side, and then the top view at the top. But if a right view has been given, then that detail of the right view will be placed on the right-hand side over there. Front view to the left and the top view from the top. So that's what you will see in that regard. All right. So therefore, you start from the bottom. Teach the learners to start from the bottom. Don't use the biggest possible block method. Why? Because if it's slanted deeper in a learner draw it in here at the front, then obviously you will lose the marks for not showing it to the deeper end of it. It will only get marks for the front part and the front parts over there. So please don't use the biggest possible block method. Rather use from the bottom upwards and then finish it off there. And then if there's more detail going further onwards, once you're done with the bottom part, you can build up and build up to the top part of it. All right. So how do I do this part over here? It's 20 millimeters. So you take your set square and you slide your set square on your T-square the whole time. The T-square you slide with your drawing board to the left-hand side the whole time. Okay, so it goes from there 80 millimeters. So what I will do is I will simply slide my set square on 30 degrees and then draw the 80. And then on this side over here, I've got my 40. Draw it out, complete this part over here, and also complete the last part. Then I go up for 20 millimeters. So take my set square and T-square, and the whole time the set square is sliding on the T-square. That is what you see over there. And then the last part is basically complete this drawing up to that point. But if the set square is sliding on the T-square and the T-square is sliding on the side of the board, you will always get those lines parallel to each other. And that is important. We use transparencies and take the transparencies and place it on top and to see if a learner have done it 100% correct. All right, so therefore, after this part, learners may use color if it helps them to understand this better. So therefore, you start at the bottom, you work your way up to the base parts, and from the base parts, you can go even further and add the small little blockies, which is those blocks over there, measure them all out. So there we go with those parts over there. And then eventually we can end up by completing this view up to that point. And then also on this side over here, up to there, bottom side, the top side, and the far end side over there, and complete the rest of it. What I want to point out to you is this portion over here. There's no solid line over there. It's not a seam. It's not pasted on. So therefore, there's no solid line at that point either. So don't show that as a solid line for the learners itself. All right. S is now the lowest point. So they will start at S. S is a point in the air. So first of all, draw the biggest possible block, measure S out, and then from there on you go and start and draw the rest of the drawing or the information from there further onwards. All right, but important, start from the bottom upwards. Don't draw a biggest possible block method in doing this section over here. This is grade 10 content, ladies and gentlemen. On this part over here, it points out to you that there's no heights been given, but it says it's 60 degrees and the direct distance is 20. So we don't know what the vertical distance is over there. So learners will obviously start at the bottom. They will go there 10 millimeters upwards. And then from there on, they need to determine this portion over here. So they can start measure it out, and then they can say this is 60 degrees 60 and that is 20 millimeters. And what they must do is they have to frame this part from corner to corner to corner to the bottom part to the corner and use this frame to redraw this on this part over here. Now obviously it does not stand there at the back, it stands here at the front, so you have to go 20 millimeters inwards. This dimensions that you have to have here is not to say that it will be perfectly dimensions. You can draw it freehand by hand, because this is a type B, actually, line type drawing somewhere on your paper. Don't rub out this part, or don't let the learners rub it out. Why not? Because the examiner is saying, where did you got the proof from to get this drawing? So therefore he wants the evidence on this part over here. Okay, so now the orientation, it's 20 millimeters inward. So if I go for that part, from there it's 10 to the left, 10 to the right, 22 to the left, 22 to the right, gives you 44 and 20. And now you can start measure the distances out from there on up to that point. And then it's 12 millimeters. In other words, it goes up 18 millimeters. Draw your biggest possible block. And then, of course, from those points up to the top, it's also supposed to go from the bottom up to the top, up to that position over there. Now, if a learner messes up this part over here, make it wrong, in other words, he will lose his marks for the auxiliary view. But now, if the learner take this wrong view, already been penalized, then measure the distances that he has got over here to transfer it over here. He shows knowledge in doing so. So whatever obscured view this is, it will still be because of the auxiliary view. He's already been penalized for the correctness of the view, so you can't penalize him again. So therefore, he will get this mark, and then from there on, it goes backwards. And if that back lines is parallel with the front lines, obviously, he will also get the marks from. So if that line is parallel with this one, although this is wrong, he will get the mark because he knows that this is parallel likewise with all these other lines parallel with each other. All right, so then complete this part over here. That is what you see in this regard. Then if you have to go for a pyramid, 45 degrees tells you it's 20 by 20. So you don't need to have auxiliary view for that because it will give you 20 by 20 on the end. So you could have just measured the 20 by 20 in over here and then start with this part. Then you go upwards. There we go with that upper part. Biggest possible block is required. So if you draw the biggest possible block, the learner can use this biggest possible block to rise the center point of 15 millimeters. So you can determine the center point by corner to corner, find that as that intersection point, go 15 upwards. You don't need to draw another auxiliary view. You can just use that tip, and then from that tip, you can simply complete the rest of it. All right, so that is isometric. Ladies and gentlemen, no circles in grade 10 content. So you can skip this part. You don't need to explain this part over here. Doesn't matter from what angle the circle is standing. It doesn't matter how it looks like. This is a more complex like drawing. So therefore you will start again from the bottom upwards. You will measure it in. You don't need the auxiliary view for that because it says it's 90 in total, 10 backwards, and it is 80 in total. And this part and that part is equal. So it's going to be 40 by 40. So you can measure this part out without doing any auxiliary view. But right, so there's the circle now, grade 11 and 12 content. But if he has to do something like this part over here, this is also grade 12 content, not to be explained. But yes, you can center out the bottom part, and you can center out the top part. You can find the center point for, in this case, maybe a square or something like that for the grade 10, but a circle for the grade 11s and 12s. And then this is, of course, a section drawing, not applicable for grade 10. It's only for grade 12. So he's going to section this part over here, cut out that portion, and complete the rest of the drawing. And likewise, I said with hatching, in this case, the hatching will be on 60 degrees and 60 degrees to other sides. All right, so that's basically what it's pointed out to you in that regard. Center lines is not applicable for grade 10 content. Okay, ladies and gentlemen, this is the grade 10 content. I'm going to round off or finish off by indicating, all right, so this is what we are explaining. So therefore the PAT research, the mechanical analytical, mechanical drawings, PAT freehand drawings for next term, isometric drawings, and the PAT exam. And of course, this exam over here. This exam, I can perhaps mention that this exam is going to consist of, okay, so I thought I will be able to complete this part on another area. Let me just quickly open this to exam papers. I just want to show you something. The grade 10s for next term's assessment framework. This is what I was looking for. For the grade 10s, in the June exam, March exam, teachers are responsible for the exam papers. September, teachers are responsible for 10 and 11s. But the June exam and the September grade 12 exam and the grade 12 National Senior Certificate, teachers don't need to worry about. The Free State Department of Education will be having a standardized exam paper. All right, back to June. Grade 10s will be writing only one exam in next term. All right, so that's why I'm having this exam or this session to explain to the teachers. It can be only a mechanical analytical with applicable freehand sand symbols, enlarge and reducement of scales. It can Question 2 can be geometrical constructions of polygons and ellipses. Question 3 will be isometric drawing, and question 4 will be a mechanical drawing. That is what the learners can expect at the end of term 2 for this question. All right, so for the exams, there's no paper 1 and paper 2 because the content hasn't been explained yet. So it's only one paper for the grade 10s. So that is what I want to say to you about that. And then the last part is the external moderators reports and information is talking about. I'm starting with the isometric drawing. Many candidates displayed limited skill when required to convert two-dimensional third angle graphic projection drawings into isometric drawings. All right, did not draw the required auxiliary views. Grade 10 content for the grade 12. Remember, this is grade 12, end of last year, National Senior Certificate. Isometric circles is not for grade 10. Demonstrate weak drawing skills. That is grade 10 content. Suggested for improvement, grade 10 work is the moderator is explaining, please do the grade 10 work. Skills to produce an isometric drawing requirements extensive and regular practice exercises. Practice converting two-dimensional to third graphic position into isometric drawings. That is exercises, examples. Angled or non-isometric lines, grade 10 content. Construction of isometric circles, that's grade 11. It is essential that teachers provide learners with the adequate number of appropriate isometric. Wait, quiet, please. Muted them from my side. Okay, this is essential that teachers provide learners with the adequate number of appropriate isometric course drawings from grade 10 to grade 12. Mechanical assembly. Remember that grade 10 learners hasn't got an assembly, it's only one model itself. That's question 4. Was attempted by almost all the candidates. However, the candidates' performance in 2025 was poor. There's reasons for that, so I am not going to say this is grade 10 reasons or something like that. And graphic information and numeric data, as well as the correct appliance of mechanical drawings principles, is set in the SANS symbol. I've explained to you the grade 10 content in terms of SANS, code practices, and then common errors, below average. Many candidates prepared only one view, poor planning, running off the papers, those type of things can demonstrate difficulty in measuring grade 10 content and working consistently with dimensions, grade 10 content. Many candidates, rules of sectioning, I've explained to you the sectioning. So that is basically the grade 10 content. M6 hexagonal nuts and the drawing of threads was particularly weak, so that is not for grade 10s. Read through the individual parts in the correct position. made available errors, avoidable errors and omission of center lines. Now, again, I mentioned the center lines. Overall presentation and quality of line work, grade 10 content, well below the expected standard. And then access to sufficient and appropriate resource material. This is all suggestions for improvement. Go through the SANS. That's why we have started with the SANS now already, some portions of the SANS itself, and then practice engineering, graphics and design, and DBE approved textbooks, working from other textbooks, principals responsibility. Past national senior certificate exams or past exams, the workbook is a lot of examples. So if a learner can finish his drawing in an adequate time of, let's say, for instance, 45 minutes, it means he scores during in finishing it off in 45 minutes. It means that he will be fit for the exam also to complete a assembly drawing or an isometric drawing in the required 35 or 45 minutes. Right. Orthographic projection, fundamental grade 10 content. Ladies and gentlemen, this is a grade 12 document. How many times grade 10 has been featured in here? Third angle orthographic projection. Rules of hatching, grade 10 content. Hexagonal part of fastness, that's grade 11. Teacher who advised weaker learners to simply redraw the individual parts. That is wrong. You will lose a lot of mark, or the learner will lose a lot of mark. Accuracy remains a fundamental requirement. Measurement, not the side of the ruler, but the 0 point of the ruler. Manage examination time effectively. Work fast in class. Start with the grade 10s, telling them they've got only this period to complete so that they get into the custom of working fast. So please make sure about those things. And then, yeah, that is it. But could you see how many times grade 10 was mentioned? Can you see why I'm saying that grade 10 teachers are of the most important teachers that you can get into the system? So please apply your principles. Please make sure that all the principles for the grade 10s during term 2 will be applied so that we don't get remarks like this from the external moderator in that regard. Okay, from my side, ladies and gentlemen, are there any questions? Anyone who'd like to ask something? Anyone who'd like to know something? Can I, for the last time, just quickly add the attendance register onto this part over here? Just click on the link, please, and then you can simply just open up the attendance register. This meeting has been recorded, so I'm going to put the recording off now. Stop the recording. So therefore, we stopped it now. And